What's up guys, today we're going to be talking about computational fluid dynamics. First we're going to talk about the basics of computational fluid dynamics, and then we're going to look at it through ANSYS Fluent by doing an example on a heat exchanger. What is computational fluid dynamics? It's a computer-based software that allows us to simulate and analyze the behavior of different fluids. It can be used in so many different fields of engineering, such as oil and gas, automotive, and even medical. There are 4 parts to computational fluid dynamics. The first part is making your geometry. This is the most important part because if you get the wrong geometry, then of course your results are not going to be accurate. The second part is meshing, and this is pretty much dividing the geometry into smaller segments so that our geometry is more accurate whenever the fluid flows through it or around it. So today, we're going to practice computational fluid dynamics with a heat exchanger example. So our problem has a cross-flow shell and tube heat exchanger, and we have all of our defined geometry, so we're ready to start.
All right, we're going to go ahead and open up the Fluid Flow Fluent. We'll double click. We'll right click geometry, make sure that we're on 3D. We'll right click geometry again, open up the design modeler. So first we're going to change some settings. We'll go to grid, show in 2D, and snap. Major grid spacing we're going to change to 1. Minor we're going to change to 10. So that means there'll be 10 small squares in the 1 major square. So we're going to open up a sketch in the XY plane. We'll click on the Z axis to give us a better view. So in our sketch, we're going to create a circle. And so you'll click once on the origin, and then you'll click twice to create your circle. We're then going to go to the dimensions. We'll click diameter. We'll click on the circle, and then diameter 1 is 1 meter. And then we're going to extrude, just like any other CAD system. We'll click on the sketch that we want to extrude. We're going to change this to add frozen. And then for our extrude depth, we'll go 5 meters, which is the length of the shell. And then click generate. So if you kind of move it over to the side, you can kind of see the 3D view. So now we're gonna create another sketch in the XY plane. This is gonna be our concentric tube. So we'll go back to the sketching. Draw another circle. Go back to dimensions. This one's gonna have a diameter of 0.25 meters. Repeat the same process with the extrude. Click on sketch 2. And that's frozen. And it's the same extrude depth of 5 meters. And click generate. So now you can kind of see the concentric tube inside of the shell. So now what we're going to do is we're going to go to the ZX plane. We'll click Y axis to kind of get a better view. And now we're going to make the inlet and outlet tubes to the shell side. So we can create another circle. Dimensions and problem statement 0.2 for the diameter. And then also now in the dimensions we can also add a horizontal measurement. Problem statement that's 0.1 inch of the shell. We're going to extrude again at 30. And this one, all we need is for the tube to be outside of the shell. So now we're going to insert another sketch on the ZX plane. And this will be the outlet of the shell side. Create a circle. Be the same diameter of 0.2. And we'll extrude again, or we'll actually dimension the horizontal. This will be 4.9. Now we're going to extrude, select the sketch that we need, add frozen, and then this time we're going to reverse the direction because we want the outlet to come out of the bottom of the shell. And it'll be 1 meter again and we'll generate. So now you can kind of see the 3D view of the heat exchanger. So now we're going to create a boolean, and we'll change the operation to subtract. For the target bodies, we're going to click the inlet and the outlet of the shell side. And for the tool body, we'll click the shell. And we want to preserve the tool bodies. Click generate, and now you can see that we've subtracted the material on the inlet and outlet of the tubes from the shell. So we're going to create another boolean. This time the target body will be the shell and the tool body will be the concentric tube. You can also select the body from the tree. We'll preserve the tool body. And what this is doing is basically subtracting the concentric tube from the shell. We're going to insert another boolean, but this time we're going to unite. So we're going to make the inlet, the shell, and the outlet all one body. And you can hit Control and then left click to select all of them at the same time. We'll hit generate. And now the inlet, the shell, and the outlet are all one body. And you can see on the tree we went from 4 bodies to 2. The last thing we're going to do is select both bodies and form a new part. So we're back in Workbench. This time we'll open up the mesh. We're going to right click the mesh, hover over Insert, and click on Method. For our geometry, we'll select both bodies and hit Apply. We'll leave the method as automatic and then click on Mesh in the tree. We're going to change the element size to 0.1. And when you're creating a mesh, you can kind of guesstimate this at first. And then we'll generate our mesh to see what it looks like. So this is a decent mesh, but we would like our cell size to be as small as possible to make our answer more correct. So we're going to insert a refinement. We're going to select all of the faces. And what the refinement does is it basically takes your original mesh and it makes the cell size smaller. We'll apply. We see that we have all 9 faces, and we left this as 1, but you can go higher if you need to. So as you can see, the cell size on our mesh got smaller. Now we're going to go to our face selection tool, and we're going to start naming our boundaries. So we'll select this face and right click, create name selection. This will be the cold outlet. And you'll just repeat this process for all of your boundaries. This one will be cold inlet. This is the hot inlet from the steam. This will be our hot outlet. You can see all of your name selections in the tree. So now we're going to select all of the faces, the outside faces of the shell. Right click, create name selection, and this will be the shell wall. And all of these name selections are important later when you're in the setup. So now we're going to hide the shell body, or we'll actually change the fluid. We'll change it to fluid. That way ANSYS knows that this body will have fluid running through it instead of treating it as a solid. And now we're going to hide the shell body, and we can name the inner tube to pipe wall. So now we're going to select the body selection tool. We'll create a name selection. This will be our hot domain. We'll unhide the body and select the shell. We'll create this as the cold domain. So now we can go back to our mesh. So now we're back in our workbench.